All right, today we're diving deep into a really powerful class of medications, antipsychotics. We're going to explore what they are, the incredibly complex brain chemistry they target, and of course, the key differences between the major types. Let's get right into it. So, to really get how these drugs work, we've got to ask the big question first. What is actually going on in the brain during an episode of psychosis? This is the fundamental puzzle that these medications are designed to solve.
Okay, first things first. Let's define the challenge itself. What is the condition that these powerful medications are even for?
One of the primary conditions we're talking about is schizophrenia. At its very core, this is an illness where someone experiences a disconnect from reality. And that, it immediately raises a huge question. What's happening on a biological level to cause something like that?
Well, it turns out the answer lies in chemistry, the brain's chemistry. To understand the drugs, we first have to understand the chemical story playing out inside the brain. The main idea, the leading theory that scientists have landed on, is something called dopaminergic overactivity. It sounds super technical, but all it really means is there's just too much of a key brain chemical called dopamine floating around in a specific part of the brain known as the limbic system. But here's where it gets really interesting. While dopamine gets all the headlines, it's not a solo act, not at all. Other brain chemicals like serotonin and noradrenaline are also thought to be major players in this story. It's much more of a team effort than a one-man show.
So, if the problem is a chemical imbalance, well, it kind of makes sense that the solution would be chemical too, right? And that brings us to the pharmaceutical strategy for treating it.
And here is the core strategy, and it's pretty brilliant. If you think of all that excess dopamine as a bunch of keys, these drugs work by basically blocking the locks. Those are the dopamine receptors on your brain cells. When the locks are blocked, the key can't get in and the message doesn't get delivered. That's what helps reduce the symptoms.
Now, this is a really crucial point. While all these different antipsychotic drugs are aiming for that same goal, and they all have pretty similar effectiveness overall, they do not all go about it in the exact same way. They have different strengths, different potencies, and different mechanisms, and that leads to a major classification. Which brings us to the two main families of these drugs, the typicals and the atypicals. And honestly, this is the single most important distinction you need to know in the world of antipsychotics. So what is the key difference? It all boils down to one word, affinity. Think of affinity as how tightly something grabs on. Typical antipsychotics have a high affinity for a certain dopamine receptor called D2. They grab on tight and block it hard. Atypicals, on the other hand, have a low affinity. They have a much looser grip on that D2 receptor, and they often work their magic through other, more complex pathways. Okay, so let's pop the hood on that first category. What's the deal with these so-called typical antipsychotics? You're going to hear them called a few different things. They're known as first-generation drugs because, well, they were the first ones. You'll also hear the older term neuroleptics. These were the original breakthrough medications that really changed everything. Now, inside this big typical family, the drugs are grouped by their actual chemical structure. So you end up with four main subclasses: the phenothiazines, the thioxanthines, the butyrophonones, and then a kind of miscellaneous group for the ones that don't quite fit anywhere else. The phenothiazines, these are the OGs. They're one of the oldest and biggest groups. A drug like chlorpromazine was an absolute game changer back in the day. It was one of the very first medications to prove that a chemical could actually treat psychosis effectively. Then you've got the butyrophenones. The thing to know about this group is that they are powerful. We're talking about some of the most potent typical antipsychotics out there. Haloperidol, for example, is a very strong and very well-known drug from this class. Okay, so we've covered the old school. Now let's switch gears and jump forward to that second, more modern family of medications, the atypical approach. These are the second-generation drugs, and remember that affinity we talked about? Well, their defining feature is that weaker or lower affinity for those D2 dopamine receptors. This whole different mechanism is the key because it leads to a very different profile of effects and, importantly, side effects. Here you can see some of the common atypical drugs you might hear about today. As a newer and still growing class of medication, these were developed specifically to try and refine the treatment, building on all the lessons learned from that first generation. So when you step back, you see two really distinct strategies, right? You have the old guard, the typicals with their strong-arm blockade of dopamine, and then you have the newer atypicals with their more nuanced, gentler touch.
It really leaves us with a huge question. How will these two different philosophies continue to evolve and shape the future of mental health care?